Hello again, everybody. Welcome back to the next section of solving proportions. Here we go. You should have this in front of you now. You picked it up in class or picked it up from my website. Hopefully it's there for your taking if you need it. Uh, let's just jump into some examples of how to use proportions to solve equations. Please do things like I do. I don't care if you can do these in your head. Remember, this is about how we get here. Because again, I can change all the numbers and make it really abstract and difficult. The point is how we're using the labels in proportions and how to make sure we set it up accurately. So please bear with me as we do that, because for this, I've tried to keep the numbers fairly simple for you. All right, Donna is driving a delivery van 8,000 miles in 3 days. At this rate, how far will she drive in 15 days? Okay, begin with this over here. What we know is we have a distance driven per day. Okay, distance per day. So we have a rate here, right? We have different units here. We have a measure of distance and a measure of time. So we're going to put distance, okay, over days. Let's just write that off to the side there on your left. And then let's know what we know, or let's write down what we know, that she rides 800 miles, drives. Now, would you please write it like that? Don't be afraid to write the word on your paper. 800 miles per 303 days, not 300, 3 days. So she goes 800 miles in 3 days, and it says at that rate, if that's a regular rate, how far would she drive in 15 days? So we want to set that equal to, because this is a rate, and we want to set that equal to, and we want to know 15 days. Now, we got miles, or distance over days, so we're going to put the days on the bottom. It has to line up here, 15 days. And there you have it. The top is X miles. And if we look back, the question said at this rate, how far? How far would she drive? So that's what we know. And now all you have to do is crisscross, criss and cross to solve this. 3x, 800 times 15. I went ahead and worked that out for you. It's 1200. I'm sorry, 12,000. And then we're going to divide that by 3 to solve it. Now we're just solving an equation here. And that comes out to be 4,000 miles. And that's some valuable information. If you're the person paying for the gas in the van, you'd probably want to know that because you might want to make a budget to pay for it. All right, so that's a basic proportion. But as you do proportion problems, would you please write the labels in the problem so when I look at it, I can know exactly where things are and why you set them up the way that you did. That would be very helpful for me. All right, another proportion problem. Okay, go down the page there for you. To control a fever, a doctor suggests that a child who weighs 28 kilograms be given 320 milligrams of Tylenol. If that dosage is proportional, they tell us that, to the child's weight, how much of the Tylenol is recommended for a child that weighs 35 kilograms? Okay, so over here, what we're going to do is we're going to put the dose, it's the milligrams, over weight. The dosage over weight. So we're going to put the dose as the numerator, dosage. And we have 320 milligrams, okay, for a 28 kilogram child. So 320, that's milligrams. Please label over 28 kilograms. That's equal to, all right, we want to know, well, how much is recommended if they weigh 35? So that's the child's weight. That's how much, if you have a 35 kilogram person, you want to know how much. So to solve this, now we just have to crisscross and multiply. So we're going to multiply those two and those two to find the recommended weight for a 35 kilogram child. X times 28, crisscross, multiply, 28x is equal to 320 times 35 You can double check me, but I believe that's 11,200. Solve that for x, divide by 28. There's your 1, that cancels out. X is equal to, that comes out to be 400 milligrams. And if you look at those numbers, that would make sense. 320 for 28, so that's a little bit more, and that's a little bit more. And that would be, I think, a pretty good estimate right there, 400 milligrams. Again, proportion used to solve a problem where you can narrow it down to just one unknown question. We can also use proportions to solve unknowns for similar objects like this. Let's say you have two shapes that are similar. Similar means basically it's the same shape, it's just been shrunk or increased in size proportionally. And what we know is that in similar shapes that corresponding sides are proportional. Okay, if shapes are similar, corresponding sides are proportional. Corresponding sides are proportional. So what that means is if I look at this, I'm just going to go large over small. And if I can identify corresponding sides, for example, this 10 corresponds with that. Now if you look at the figure carefully, you see that that's basically, those are the same shape, it's just been shrunk, or the same side, it's been shrunk. So I'm going to go large over small. And honestly, you could flip this over, you could do small over large as long as you stayed consistent. But I'm just going to do it this way. If that's 10 centimeters, that means that this and this side I can put like that. And that is going to be equal to the same thing of these corresponding sides. 16 is the large over 12. Now crisscross, work it out. 16x is equal to 120 and divide by 16. And you get, just a little more room here. X is equal to 7.5 centimeters, and that is the measure of the small side there. All right. Again, proportional proportions can be used to find an unknown side between two similar shapes as long as you know one set of corresponding sides. All right, one more to get through and we'll be done, and that is how this all can relate to a scale problem. Now this is actually out of your homework for tomorrow that you're going to be doing in class. So I just thought I'd pick one from there to make your life exciting. I hope that helps. All right, we have, this is actually from page 134, number 13, and it says the scale of a map is 1 centimeter to 15 kilometers. Okay, so you have someone has made a map. For every 15 kilometers they've measured, they've made 1 centimeter on a map. Okay, so it says find the actual distance to this map measure. So on the map, you've measured 2.5 centimeters. Again, I want you to show this as a proportion, please, because I can make the numbers harder, but just show that you understand how the proportion relates to this problem. Well, here's what I'm going to do. I am going to put the scale, in other words, the map, as my numerator, and the actual distance as my denominator. Actual distance. Okay, so the scale, in this scale, 1 centimeter, on the map, 1 centimeter represents 15 kilometers. So I'm just going to put that like this. I'm putting the map measure 1 centimeter over 15 kilometers. So that's true of the entire map. So what they're asking me is if I have 2.5 centimeters on the map, 2.5 centimeters on the map, see it's right here, keep drawing arrows to it, that's the map measure, 2.5 centimeters on the map, how far would that be? How many kilometers would that be? Crisscross and find out. 1 times x, guess what that is? We like 1x because that's all we have to do. 15 times 2.5 is 37.5 kilometers. And that's an example of using a scale to solve or using a proportion to solve a scale problem. And it makes it so easy when you can do that. So that represents, or that's the end of part 2. Get it down. I'll see you tomorrow.